Jupiter, the largest planet in our solar system, is a celestial giant with a fascinating entourage. It possesses a remarkable collection of moons, each with its own story to tell. The Galilean moons, Io, Europa, Ganymede, and Callisto, are the largest and most well-known. Discovered by Galileo in the 17th century, they can be seen with a small telescope. In contrast, Jupiter's irregular moons are smaller and fainter, often captured objects like asteroids or comets. These moons have elliptical, inclined orbits, often in retrograde motion. Studying them helps us understand planetary systems and the early solar system's dynamics. The discovery of Core was a testament to advancements in astronomical observation technology and the dedication of astronomers. In 2003, Scott S. Shepard's team at the University of Hawaii searched for distant objects in the outer solar system. Using Mauna Kea's telescopes, they captured multiple images of the same sky region over several nights. On February 8, 2003, they noticed a faint, slow-moving object. Further observations confirmed it as a new moon of Jupiter named Core. This discovery enriched our understanding of Jupiter's dynamic system of satellites. It highlighted the vastness and unexplored nature of our solar system. Core's orbit around Jupiter is a captivating example of the diverse and often peculiar motions of celestial objects within our solar system. Unlike the nearly circular and equatorial orbits of the Galilean moons, Core's path around Jupiter is highly eccentric, inclined, and retrograde, making it an intriguing subject of study for astronomers. Core's orbit is characterized by its retrograde motion, meaning it revolves around Jupiter in the opposite direction to the planet's rotation. This unusual orbital characteristic suggests that Core is not a native moon that formed alongside Jupiter, but rather a captured object, likely an asteroid or comet, that was ensnared by Jupiter's powerful gravity. With an average distance of about 24.5 million kilometers from Jupiter, Core's orbit lies far beyond the orbits of the Galilean moons. It takes Core approximately 777 Earth days to complete one orbit around Jupiter, a testament to the vast distances involved in the outer regions of Jupiter's gravitational influence. Core's orbit is also highly inclined, tilted at an angle of approximately 141 degrees relative to Jupiter's orbital plane. This significant inclination, combined with its retrograde motion, suggests that Core's capture into Jupiter's gravitational embrace was a complex and chaotic event, likely involving interactions with other celestial bodies. Observing Core from Earth is a challenging task due to its small size and immense distance. However, astronomers have been able to glean some information about its physical properties through careful analysis of its faint light using powerful telescopes. Based on its brightness and assuming a typical albedo for small icy bodies in the outer solar system, Core is estimated to have a diameter of approximately 2 kilometers. This makes it one of the smaller irregular moons of Jupiter, highlighting the challenges in studying these distant and diminutive objects. The exact composition of Core remains unknown. However, based on its location in the outer solar system and its likely origin as a captured object, it is thought to be composed primarily of ices, such as water ice, mixed with rocky materials. This composition is similar to that of many asteroids and comets, further supporting the theory that Core is a captured object. The surface of Core is likely heavily cratered, bearing the scars of billions of years of impacts from smaller objects. This bombardment is a common feature among celestial bodies in the outer solar system, where the vast distances between objects do not prevent occasional collisions. Section 5. The Pasiphae Group, Core's extended family. Core is a member of a group of irregular moons known as the Pasiphae Group, named after its largest member, Pasiphae. This group is characterized by their retrograde orbits, high inclinations, and similar distances from Jupiter, suggesting a shared origin. The Pasiphae Group is thought to have formed from the breakup of a larger captured object, likely an asteroid, that was torn apart by Jupiter's tidal forces. The fragments from this disruption then settled into their current orbits, forming the Pasiphae Group we observe today. The moons within the Pasiphae Group exhibit a range of sizes and orbital characteristics, with Core being one of the smaller members. Despite their shared origin, the individual moons within the group likely experienced slightly different evolutionary paths, leading to variations in their current properties. Studying the Pasiphae Group as a whole provides valuable insights into the processes of asteroid capture, tidal disruption, and the long-term evolution of irregular satellite systems. By comparing and contrasting the properties of individual moons within the group, astronomers can piece together the history of this ancient celestial collision. Section 6. Kor's name, a mythological connection. In Greek mythology, Kor, also known as Persephone, was the daughter of Zeus, or Jupiter in Roman mythology, and Demeter, the goddess of agriculture. She was abducted by Hades, the god of the underworld, and taken to his realm. Demeter's grief over her daughter's disappearance caused the earth to become barren, leading to famine. Zeus intervened and negotiated Persephone's release, but because she had eaten food from the underworld, she was bound to spend part of the year there with Hades. This myth explains the changing seasons, with spring and summer representing Persephone's time on Earth with her mother, and autumn and winter representing her time in the underworld. The name Kor, meaning maiden or daughter in Greek, reflects the moon's status as a satellite of Jupiter, the king of the gods. The mythological connection adds a layer of cultural and historical significance to this distant and enigmatic celestial body. The practice of naming celestial objects after mythological figures is a long-standing tradition in astronomy. It reflects the human desire to connect with the cosmos and imbue these distant objects with meaning and stories that resonate with our own experiences. Section 7. The scientific significance of studying Kor. While Kor may seem like a small and insignificant object in the vastness of space, its study holds significant scientific value. As an irregular moon of Jupiter, Kor provides a unique window into the early solar system and the processes that shaped our cosmic neighborhood. The study of Kor's orbit, along with other irregular moons, helps astronomers understand the dynamics of planetary systems and the mechanisms by which planets acquire and retain their satellites. The retrograde and highly inclined nature of Kor's orbit suggests that it was captured by Jupiter's gravity, likely during a period of intense bombardment early in the solar system's history. Analyzing the composition of Kor once we have more detailed observations can provide clues about the building blocks of the outer solar system and the conditions under which these objects formed. The presence of certain ices or minerals can indicate the temperature and chemical environment of the region where Kor originated. Furthermore, studying the Pasiphae group, of which Kor is a member, allows astronomers to investigate the consequences of celestial collisions and the processes by which asteroids and comets can be disrupted and incorporated into planetary systems. The shared origin and subsequent evolution of the Pasiphae group provide valuable insights into the chaotic early solar system. Section 8. Mysteries yet to be unraveled. Despite the knowledge gained from telescopic observations, Kor remains an enigmatic object with many mysteries yet to be unraveled. Its small size and immense distance from Earth make it a challenging target for detailed study, leaving many questions about its nature unanswered. The exact composition of Kor is still unknown. While it is assumed to be primarily composed of ices and rocky materials, the specific proportions and the presence of any unique minerals or organic compounds remain a mystery. Further observations using spectroscopy, which analyzes the light reflected from an object, are needed to determine its composition more precisely. The surface features of Kor are also largely unknown. While it is likely heavily cratered like other objects in the outer solar system, the size, distribution, and composition of these craters are unknown. Higher resolution images, potentially from a future space mission, would be required to resolve these surface details. The internal structure of Kor is another area of uncertainty. It is unknown whether Kor is a differentiated body with distinct layers or a relatively homogeneous object. Understanding its internal structure could provide insights into its formation and thermal history. Section 9. Conclusion: a small moon with big secrets. Kor, a small and distant moon of Jupiter, may seem like an insignificant object in the grand scheme of the cosmos. However, its discovery and subsequent study have provided valuable insights into the formation and evolution of planetary systems, the dynamics of celestial mechanics, and the chaotic early history of our solar system. Despite its small size and the challenges of observing it from Earth, Kor has revealed itself to be a fascinating object with a rich history. Its retrograde orbit, membership in the Pasiphae group, and likely origin as a captured asteroid all point to a dynamic and eventful past. As our understanding of the universe expands and our technological capabilities advance, we can look forward to uncovering more secrets about Kor and other distant celestial objects. Each new discovery brings us closer to comprehending the vastness and complexity of the cosmos and our place within it.